All right, so I've had a lot of people who feel like they're getting stuck in this stoichiometry, and maybe it was making some sense at the beginning, but you're getting more and more lost the more stuff we do with it. And so I wanted to put this together just to have a slightly different approach or explanation to these problems, because the way that I'm explaining it has been kind of consistent and simple in class, but if that's not working for you, I wanted to change my approach just a little bit to give you what you need. So what I'm going to be kind of focusing on and basing most of my explanations on in all of the problems I'm working out here is this map. And I talked about this map briefly in the very, very first podcast, but I tried not to come back to it too much because this can really become a crutch for people. You're learning to drive right now. If you drove everywhere with a map in front of your face, or by following directions and never paid attention to the street signs and learned to navigate how to get from home to school on your own, you'd be stuck using that map, be stuck using that navigation every single day. And that's going to take a while, and you're not going to have the same freedom and skill at driving as if you were learning to navigate and drive on your own without that guidance. So I'm always hesitant to tell people just use the map, because the map you can still get lost on, and then once you're lost and you can't trust the map, or you don't know how to use the map, then you're completely lost. So I try and teach you how to work without the map. But if you're so completely lost in all the stoichiometry stuff, I'm giving you back this map, and I'm gonna encourage you to use it even on a test, because what's important is that we're getting to our destination one way or the other. And we'll work on kind of weaning you off of this map as we get farther and farther into the year, because there's still going to be stoichiometry even in the very last unit, just a little bit less, and the map might be a little bit different. So let me explain this map a little bit more in detail. What we're going to do, what we see over here in red, is all of the stuff talking about our first substance, substance A. And A is just a placeholder depending on what reaction you have in your question and what specific substances it has in there. But either way, we're going to be starting with this A stuff. And that question is either going to give you grams or moles of A. Those are the only two units we can have. And so you'll notice here our path to getting to our unknown, our substance the question's asking for, substance B, is a little bit longer if we start with mass than if we start with moles. Moles is a little bit closer to getting to those unknown B unit substances. So that's kind of the idea here, is that we can kind of see what's in our way as we're going from whatever we're given over here and trying to get to what the question is asking for, what is unknown over here. And every single question we work, all of this stoichiometry stuff, is always going to involve two different substances, an A and a B. And because of that, every single question that we work out is going to have this mole ratio thing in it, where we look at the balanced equation and it tells us, for example, 2A plus 1C makes 3B. I don't know what those really are because this doesn't make sense from a chemical and element perspective, but still, if this was my equation, I'd be taking a 2 and the 3 from in front, those coefficients, and using those in my mole ratio to convert from A to B. Every single question is going to involve moving from one substance to another using that mole ratio. But some of our substances, or some of our questions rather, require more steps. So as you can see, this mole ratio would be the step, and the only step we need if we're given moles of our first substance and it asked us for moles of that second substance. That's all we'd need to do. But if instead we were given mass of that first substance, grams, then before I can even get to that mole ratio, if I'm trying to still get to moles of that second substance, before I can do my mole ratio, I have to get to those moles, which means I'm going to need to first use my molar mass. I'm going to have to look up and whatever A is on the periodic table, and that's going to tell me how many grams per mole that is, meaning I'm going to have to use this conversion first in my dimensional analysis, that's stoichiometry, to get to moles, and then I'm going to be able to use that same mole ratio as before to get to moles of B. So having those grams there makes my problem a little bit longer. But that's all that I really have to do once I have this map, is ask myself, what am I given, mass or moles? What is my unknown, moles or mass? And once I know that, I know where I'm starting, and even if I'm going all the way from the beginning to the end, then I know every step I'm going to have to take to get there. If I'm starting with grams and I'm ending with grams, that's those problems that have three conversions. You start with a molar mass, and you do a mole ratio, and then you end with another molar mass of that second substance. So that's how I'm going to be using this, and it makes a lot more sense when I put some real questions to it instead of just dealing with this A and B stuff. So that's what I'm going to be doing in the rest of this video, is looking at some of the questions you have on pages 4 and 5 of your packet and analyzing them with this map in order to put together how they should be set up and worked out. But before I get into that, actually, once you have those conversions there, you still have to be able to put those numbers where they belong. So we talked about how to figure out what conversions you need, and we'll spend some more time on that. But one of the things you've probably heard me say over and over again is this diagonal rule. This is how we decide, because there's two sides to any equation. If we use molar mass as an example, those equations had some number of grams that came from the periodic table equal to 1 mole. And each of those equations or conversions are going to get kind of split up into the top and bottom of a single bracket. Conversions here, the either side of the equal sign just go on either side of that bracket, top versus bottom, instead of left and right, but they still stay together. And so if I know I need to use the molar mass, if that's my first step in a problem, and the map tells me find that molar mass, that's my first step here, then your given has grams there, and because those grams are on top, you're not just going to be finding that molar mass. That number that you found that goes along with those grams are going to be the very first thing that you write on the bottom of that next bracket because of our diagonal rule. Grams of one thing on top, you gotta have grams on the bottom. So even once I know that I'm using this conversion, it has two sides. I've got to make a choice of what to write down first and what to put on that bottom part. And that grams part is going to go on the bottom, which technically means this right here would be 1 mole of A up on top, because that other side of our grams is always 1 mole, and that goes on top in this situation. If instead, and I'll clear this out, let's say I got this other problem that I've made up down here. Let's say that I was starting with my given, whatever that number was, with moles of A. And that means my first step is going to be a mole ratio from my balanced equation if we looked at that map. Let's say I went and I found my mole ratio. Well, there's moles on each side of it. That's not the part that's going to matter right here, right now. It's the substance. The substance needs to match on that diagonal as well. So because A is the given substance that's up here on top, I'm going to need to make sure that moles of A go on the bottom of that next bracket. So in my mole ratio, that means that that 5 is going to be going down on the bottom. And because this side of my mole ratio was being forced onto the bottom, we have to keep that equation, that conversion together. It means the other part of that equation is going to be filling in the top. So 3 moles B would go there on top. Now, let's imagine a very similar situation. This technically wouldn't happen according to our map, because we'd always be starting with A and ending with B because they're just placeholders. But let's imagine I was starting with moles of B, following through our diagonal rule with that same mole ratio. If I'm trying to use that same ratio, now because B is on top of this bracket, that means moles of B have to be on the bottom. That diagonal rule says that moles of B would have to be on bottom. So that means that the 3 part would go on bottom in this setup, and that would force those 5 moles of A onto the top. So I haven't worked out a single question, and I feel like we're probably taking too much time on these basics, but this is all of the skills that you need in order to be able to set up and work out problems, which is why I wanted to reinforce these here. So also in general, sometimes people like steps. I feel like this is a lot of steps to working out a problem, and if you start just getting caught up and you're like, oh my gosh, there's 7 steps, it really isn't 7 steps. It's just how we could break this down into little bite-sized manageable things. So of course, in all of these problems, we need to have a balanced chemical reaction. So I'm not going to be focusing on that part now, but you either need to write it out or balance it or both to make sure that you're ready to work out these problems. And then before we can even look at the map, we need to read through the question and figure out what numbers and units were given and what the question is asking for, what the unknown is. And that's going to be setting up our question so that we can look at the map and use that to figure out what numbers we're going to need, start using that diagonal rule to put all of those things together. And then once we're done, we can do all of the multiplying and dividing to find the real answer. We round the answer and add units and substances. So those last few are really like just finding the answer, but I broke that down to make sure we remember all of those things we got to do once we get there. So this video really is focusing in here, and I'll just clear this out this way. We're really focusing on the steps 2 through 4. It's how to put together that stoichiometry stuff. If you're struggling with how to calculate it, please let me know, because once you get it set up, there's a couple options on how to calculate it, and some people when I say it one way, it doesn't make sense. So we can look at what other options you have for getting those right answers. But this is really the crucial part of putting it all together so that you can get the right answer and the right units there. So let's look at a few problems and go through this process. You'll notice on each of them, I have our little map up at the top. So I'm going to be using that to guide what I'm doing. If this helps you, my recommendation is copy down this map someplace, and like maybe in pen, and then you can fill out all the same things and do what I'm doing maybe in pencil, and then in between you can erase it, or better yet, write it out and get it laminated so you can write all over it and erase it in between. So this is page 4, question number 1, and it's great because it already has a nice balanced equation for us here. So we can just jump straight into reading the question, finding what it gives us and what it's asking for. So we want to find moles of CS2 when 6.3 moles of carbon react. So this is my given. So this is what I'm starting with over here. And if you notice, that is moles. So we're not starting with mass, which means we're not going to need the molar mass of that. And I'm honestly also going to replace this A with a C, because that's what we're starting with, is moles of carbon. And then we're trying to find moles of CS2. So our unknown is also moles, and our second substance is CS2. So once again, because we're not going to mass of B, we don't need this last step here. So what this map is telling me is that all I should need to do is look at the numbers from that balanced equation and write a mole ratio from moles of C to get to moles of CS2. And if we look at that balanced equation, there's a 5 in front of the C. So I'm putting my 5 here with the C. There's no number in front of CS2, so we know if that's blank, it's understood that that should be a 1. So this 5 mole C to 1 mole CS2 is the only thing that I should need, the only conversion step I should need to get from where I'm starting to where I'm ending. So we always start our problem with our given number, unit, and substance. And here, following our diagonal rule and just only using this one conversion here, if I look, I've got moles of C here, so I know I need to have moles of C on bottom, and that means I'm going to be bringing this 5 down to fill in that space. And if that went on bottom, then that 1 mole of CS2 goes on top, and that's it. That's our setup here. So I should just be multiplying the numbers on top, dividing by this number on the bottom, and that should get me my correct answer, which is 1.3 moles of CS2. I have all the answers posted online, but I'll go ahead and tell you that. So go ahead and check your work. Make sure that your calculator is not CO2, CS2, giving you this same answer here. But that's all that this really involves. And the next problem is also a mole-to-mole problem. So you should only need the numbers from this balanced equation to help you set up part 1b. It's just going to be a little bit different of an equation because it's giving you moles of SO2 and asking you for moles of carbon. So that's probably going to be a 5-to-2 ratio that you're using there. And be careful how you're setting that up. But that answer should end up being 18.1 moles if you're doing that correctly. So let's look at another problem. Page 4, number 2. I went ahead and balanced that equation just so that we would be ready to work with it. And so here, as we're looking at our question, analyzing, finding that given and our unknown, my given is 35.3 moles of silver. Oops. So I'm given moles again. I don't have mass, which means I don't need the molar mass of silver. Oop, I almost stopped reading. Silver nitrate. That's this stuff here. Are reacted, and it's asking us how many grams of silver are produced. So here's my silver, and it's wanting grams. So that does mean I'm going to be going a little bit farther than last time. I'm going to put a star here because that's where I'm trying to get to. So this means I'm going to have to do 2 different steps to get there. That first step is going to be the same as before. We're going to use the balanced equation to convert from one of these things to the other. And if you notice, because I circled these things in the equation, it's almost like I don't have to write them out up here. This is 2 moles of AgNO3 to 2 moles of Ag. If you remember you're doing a mole ratio there, you might not have to physically write these out and change your A and your B correctly. But I am going to try and model this once we've decided what we've got here. So I'm going to be using this ratio. And then after I use that mole ratio, I'm going to need another number. So I could do this later once I'm ready to actually use this number. But what I like to do and what I put in our process after we figure out where we're starting, where we're ending, would be to find these numbers so that we're ready to use each of these conversions. So what this tells me is to go look at the periodic table and find that Ag thing that I've got and add up that mass. Well, I don't really have to add it up. It's just sitting right there. If that was something like AgCl, I would have to add Ag and Cl. But because it's just Ag, I can just go and look at that Ag number. So, this is looking a little bit messy, but it's not that bad. So I'm starting here with my 35.3 moles of silver nitrate. And the first step for me to get out of what I've got and be moving forward is to use this 2-to-2 mole ratio that we already found here. And even though the numbers are the same, we do have to be careful. If AgNO3 is what's on top, that's what I'm going to be bringing down diagonally, is the 2 moles of AgNO3. And if this part went on the bottom, then this part is filling in the top. And then from here, we have one more step. We're not done yet. I know I'm not quite to what I wanted. And this next step is where I'm using this molar mass equation. And if we look at those two sides, I'm trying to decide if I'm going to be putting the grams side of that on the bottom or the 1 mole part of that on the bottom. And when we look at the top of the previous bracket, that's moles of Ag on top. So I know I need those moles, and specifically 1 mole of Ag on the bottom, and that mass, those grams of Ag, can go on top. And this answer, I know the answer I posted was rounded a little bit, but if you're getting this answer out, that is the correct answer. You're just supposed to round that to 3 significant figures, so this would round up to 3810 there. So let's do a couple more. I'm not going to set all of these up completely. I'm just going to help you kind of analyze them a little bit more to see how this map can help you and get the numbers that you're going to need. So here it's asking us if I have 32.5 grams of ZnSO4, and what that means for me is my given A substance is ZnSO4, and it is grams, so I'm starting here at the farthest back point that I can, which does mean I'm going to need to add up this molar mass of ZnSO4, which, helping you out a little bit, Zn plus S plus 4 O's is 161.442 grams ZnSO4 in 1 mole ZnSO4. And then it's asking us to find how many grams of BaSO4 we're looking for. So I'm looking for grams, so I want to end up here at my mass, and BaSO4 is my substance B. So acknowledging that the substance I'm ending up with is going to be BaSO4, and I am wanting grams, that also means I'm going to need the molar mass of that BaSO4 stuff. So if we add that up to 33.39 grams of BaSO4 for 1 mole BaSO4, then I can look at my balanced equation, make sure that those numbers end up here, and now I know I've got all of the numbers I'm going to need for this setup, and now I can just work my way through and write my given out at 32.5 grams of ZnSO4, and I'm not going to set up the rest of it. I want you to work your way from where we're starting here with that given. The first thing you're going to do on your way forward, trying to get to that final answer, is to use this molar mass. After you've done that, and be careful about your diagonal rule, your next step is going to be that mole ratio, using this 1-to-1 ratio and setting that up carefully. And then you're going to do one last step with this molar mass and setting that up so that hopefully by the end we have our grams of BaSO4 that it was looking for up on top. That's what we want to end up with. So we want grams BaSO4 up on top at the end. Now I'm going to do a couple more of these kind of like that. Once again, I'm helping you out with the reaction part of it. This one is asking us how many moles of carbon dioxide are formed. So even though that's my unknown, since it came first, I know I'm only looking for moles of that carbon dioxide stuff. So if I'm stopping at moles, I know I'm not going to need the molar mass. I'm not going to waste any time trying to add up CO2's mass here, because we don't need it. And this one does give us 44 grams of CH4. So the given is grams. So I'm starting back here with our CH4 stuff. So as I'm looking at my path, I can tell my first step is going to need me to add up that molar mass, C plus 4 H's, and use that number. Then I'm going to need to look at the balanced coefficients for CH4 and CO2 to make a mole ratio with them, and that's going to be my second step as I'm moving forward. And then, oh, that's going to get me to what I wanted. It's going to get me to my answer. So I'm only going to need those 2 steps in order to solve this problem. So go ahead and try adding up that molar mass. It should be about 16-ish, but make sure you don't round it. You use all of those numbers, all of them straight from the periodic table. And then we have this CH4 CO2 here as our last conversion, last step before our answer. And this answer should come out to be a little more than 2.5, between 2.5 and 3, if you're doing it correct. Or you can go and check your answers on Canvas. So this equation, definitely one that I want to help you with a little bit. It's not going to have a reaction that's quite that involved on the test. As we're analyzing this question, you can see my given is right up front, 43.5 grams of barium sulfate. So I'm starting here with the mass of my barium sulfate, and it's asking us how many moles of sodium sulfate reacted. So I'm only trying to find moles of my unknown, moles of sodium sulfate. So once again, I'm not going to need all of this molar mass stuff for sodium sulfate. I should just need 2 steps, a lot like what we did in our last setup. It's just different substances and a different reaction. But hopefully that process is similar enough that you don't struggle with it too much. And then I think this is the last one that I look at with y'all, just to, get you going. But here's our grams of NaOH. So our given is grams, or mass, again, of NaOH. To kind of help you there. And then it's asking us for grams of water. So I am going all the way over here until I get grams of water. So that'll help you figure out what substances to put in your mole ratio, what substances you might need to add up some molar masses of, and when you even need to worry about finding those molar masses. This is going to be one of those longer problems again, but this will help us find the numbers we need, use them in the correct order, and the only other thing we need to remember is that diagonal rule for how to choose which part of these equations goes on the top or the bottom of each bracket. But this is in order what numbers you're going to need for each conversion. So I hope that helps some. If it doesn't, I do have one other way that I've learned to kind of explain it to students. If you have some kind of inkling of how to set up and work out some stoichiometry problems, I can probably help you kind of take what you understand from one to apply it to the others. But this is probably the best, most powerful way for you to do things right now. Even though you need a map, as long as you learn how to use the map the right way, then you can probably work out every single problem now. So let me know if you have any more questions. Thanks for sticking with this, kind of long video, but hopefully the effort you're putting in here to get these basics are going to carry over through the rest of the unit and help you on your test too. So, bye!